Alright, so this is our next question from Cat23, the first lot. You can pause this video and give this a try, and then you can resume for the solution. I think it's a very doable question. The only problem is the mod. People are not very much comfortable with dealing with the mod sign. So let's remove the mod sign first. I'll take two possibilities here. The first possibility is that x would be greater than 0. If x is greater than 0, in that case mod x would simply be equal to x, right? And whenever x is less than 0, we can say that mod of x will be equal to minus of x, right? So let's take our first possibility. When x is greater than 0, we can say that mod x will be equal to x only. So the equation would become 2 into x square plus 1 will be equal to 5x square, right? So x being greater than 0 will get cancelled from both sides, and we get a quadratic. 2x square plus 2 would be equal to 5x. Take 5x on the left hand side, we have 2x square minus 5x plus 2 is 0, right? This is a quadratic equation which we can very easily factorize, and we can get 2x minus 1 into x minus 2 would be equal to 0. Although we have also seen a quick shortcut for such cases. We need to find out two numbers whose product is 4 and the sum should be minus 5. So the numbers would be minus 1 and minus 4. The next step is we change their sign, we get 1 and 4, and the last step is divide by the coefficient of x square. So the roots very easily we can get as 1 by 2 and 2. But the question wants the number of integer solutions, right? So we need not take 1 by 2. We have got one integer solution as 2. Now guys, after doing this procedure, we can very clearly observe that in the next case also, we will get a similar equation, but the only difference is we will have a minus 5x on the right hand side. So we are going to land up with the quadratic 2x square plus 5x plus 2 is equal to 0, right? And in this case, the roots would be minus 1 by 2 and minus 2. Minus 1 by 2 is not an integer. The only integer here is minus 2. So generally people settle down for these two values of x, and they say that the question will have two solutions, but we are missing out the point that x can also be equal to 0. We have a third possibility where x is equal to 0, and x is equal to 0 will satisfy the equation LHS is equal to RHS, 0 will be equal to 0, right? So yes, one more solution will be x is equal to 0. So 2 minus 2 and 0, I have basically three integer solutions to the given question.